Here we use the eye model to simulate two eyes. In this graphic, we have two eyes looking at a target at 1 meter, and they have some vergence or rotation to the eyes while they look at this point. So let's kind of zoom in there a little bit. You see we have rays from that source target going into both eyes. There's another graphic, or a top view. So anything we can do in AHEM with one eye, we can do with two eyes, and we can also assess the vergence and what happens to the image from the vergence when we use binocular modeling. So let's run through AHEM in a binocular mode. I'll load my settings file. And here's my first basic setup screen. So now we have two eyes that we're using, and I'm using an incoherent mode, one wavelength, and I'm going to stick with the AZ basic model. So both eyes will have this basic eye model. So these are going to be emmetropic eyes. There's no emmetropia on any of the eyes. I've got a pupil size of 7.5 millimeters, and I've set my target distance to 1 meter. So the eyes are not looking at infinity now, they're looking at 1 meter. So they're going to need to accommodate the image for 1 meter as well. So we'll see that in a second. So here's my retinal image window. I've got faceting of 5 and some typical setup features. Click OK. Now I get a new window of binocular settings, and I get a setting for interpupillary distance. So that's the separation distance between the center of the pupil of both eyes. Different people have their eyes separated different distances, so 55 is a fairly average number. Here we see the horizontal vergence for both eyes. We see I1, I2 now specifying each new parameter that we have. So we've got some rotation to the eye now. Here it's just over 1.5 degrees. One eye is turning inward, the other one, well, they're both turning inward. So one is positive and one is negative. So we see both eyes and their parameters set up next to each other for comparison. So the next screen shows the AZ lens geometry, because that's the lens choice that I chose for both eyes. And now we're seeing it particular for I1, because they don't have to be the same for each eye. We can set the models independently of each other. But this is the basic geometry for the AZ eye model for I1. And notice that I have put 1 diopter of accommodative power on the eye lens. I've moved my target to 1 meter from infinity, so now I need to accommodate 1 diopter. The inverse of 1 meter is 1 diopter of vergence. So now we have I2, and we have similar eye geometry settings. I also put a diopter of accommodation on that lens, and this is my basic geometry settings for I2 now. Click OK, and draw my geometry, and rays are being traced. So I get some graphics, some additional graphics when I use two eyes. So I get a point spread function, and you can see that there's a certain amount of shift off the center of the retinal window that I selected, because the eye has rotated 1.5 degrees. So we actually see that showing up here in the retinal image window. And we also see it for I2. It's just gone the other way, because there's I2 is rotating inward and I1 is rotating inward, so you'll see them go outward. So we have a retinal image for I1. We have encircled energy for I1. And we also have overlain retinal PSFs. So these eyes were basically the same as far as aberrations and being emmetropic and accommodated 1 diopter, so their point spread functions are very similar. So here's the I2 retinal image, So I can look at each one independently or overlain. So there's I2 retinal image and I2 encircled energy. And once again, here's our 3D view. And we can look at our eyes and rotate them around and see it this way. So in summary, any operation that we use AHEM for, we can do it for two eyes as well.